Okay, thank you, Rebecca. Okay, our final topic for this afternoon is parallel universes. Neda Kooklani, and this is Casey Durante's physics student.
Hi, my name is Neda, and today I'm gonna talk about the theory of the parallel universes. In order to do that, I'm gonna talk a little bit about quantum mechanics. And at the end, we're gonna have a little bit conversation and discussion about the validity of the theory. The idea of quantum mechanics started with the dual functionality of light. So light can act as a wave and also as a particle. How is it possible? You can see there's a very simple setup here. So light coming from one source and is passing the first screen and is shining on the second screen. So if light was only a particle, what you would see on the second screen would be just two straight lines. But you're going to see a pattern. And why is that? It's because the pattern is the result of interference of the waves. Meaning that light has a wave nature, and these waves interfere, and that's why you see a pattern. And that was convincing for most of the scientists. The original experiment was done in 1801 by Thomas Young, and for about 40 years, scientists were thinking that light is actually wave. But it was not as convincing for Einstein. So he did his own set of experiments, which was a photoelectric experiment. So imagine a metal plate, and then he would shine a very high frequency of light on the metal plate, and the result would be electron emitting from the metal plate. So how he explained it, he said that light includes thousands of tiny packets called protons. So light acts as a particle and as a wave. And that leads us to a very interesting theory which was brought up by Louis de Broglie, and he said that everything, existence, has a dual wave particle nature. So it is not only light that can act as a wave and as a particle, everything has a wave. And you actually, he brought up a formula that you can count everything's wavelength. So now let's talk about the uncertainty principle, because it is one of the most important discoveries in the history of science. And it was discovered first by Mr. Heisenberg. So he said that there is an uncertainty between the position and momentum of a particle, meaning that you cannot calculate the position and momentum of a particle at the same time. There's always going to be an uncertainty. So now let's do a very interesting experiment. Imagine that we have a cat in a box, right? And then we have a radioactive material also placed in the box. So now, if the radioactive material starts to decay, it will break a glass of poison gas, which will kill the cat. But here's the interesting thing. According to quantum mechanics, an uncertainty principle, after an hour, the cat is dead and alive. And I know it doesn't make that much sense, but believe it or not, it has been mathematically proven. So, how do we explain this phenomenon? There were many explanations after that. It was a hot topic back then, but one of the most important ones that still people think that it is given us the best explanation is the many-word interpretation. It states that the reason that we only see the cat dead or alive because it is what the observers see. This reality that we see is dependent on the observer. Imagine an independent reality, a reality that possibilities will not collapse. So each possibility will branch in a different direction. So there is a dead cat and there's an alive cat, which is just branch in a different direction. So there are many different worlds which are parallel to each other, so they won't collapse. And that's why the possibilities won't collapse. So now think about it. Think about all the important moments in the history of our planet. Imagine like the extinction of dinosaurs, or the Big Bang, or the mutation that resulted in evolution of humans, World War II, all that really incredible things that happened. Imagine that they either didn't happen or happened, but in a different time, in a different universe. So imagine that there is a universe, like one of these universes, that the mutation that resulted in the evolution of human beings happened 10 billion years ago, years earlier than what it happened for us. So they are 10 billion years more advanced than us. Imagine that there is a universe that World War II didn't happen, or many other things that happened didn't happen, or happened in a different time, or in a different way. Or even in like everyone's personal life. Everyone has memories that they don't want to remember. Everyone, they wish that they didn't happen. Everyone has made some choices that they regret. They wish they didn't make these choices. Like for instance, I'm sure that everyone come across a situation that they thought that they might have an accident. They're like, oh my God, I'm really happy that it didn't happen. What if it happened, but in a different universe? Or vice versa, many painful memories that happened, and people don't want to think about it. So the many-word interpretation so far has been given us the best basically explanation for the problem of quantum mechanics, but it hasn't been proven yet. So how can we explain the problems of quantum mechanics if we don't really have any explanation for it? And how can we accept many-word interpretation without completely proving it? So this is something that, you should think about it, and I just think that human knowledge is still limited when it comes to solving problems like this. Thank you. Is there any question? It might, because in the theory of parallel universe, because they are parallel, they shouldn't collapse. But who knows? I mean, you might travel between them in your dreams, but I mean, in like not physically, in somehow. But this is just a theory, and it hasn't been proven yet. And there's actually a lot of arguments against it. But basically, so far, this has been the best idea, I guess. Any other questions? Go ahead. Okay. Well, quantum mechanics is, I didn't really go into details of everything about quantum mechanics, but I just went to the discoveries in quantum mechanics that led to the idea of parallel universes. But quantum mechanics is a completely different topic that it takes another 20 minutes, at least. Any other question? Thank you so much, guys.
I want to thank everybody for coming out on a Thursday afternoon of finals week to support our science students. That's outstanding. Thank you very much, and that concludes our event. Thank you.